Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 11, which is basically the second lecture of chapter number 2, Vectors and Equilibrium. In the previous lecture, we have discussed about vectors, difference between scalars and vectors, and Cartesian coordinate system. After listening to the lecture, you would be able to explain addition of vectors, properties related to addition of vectors. You would be able to analyze numerical problems and multiplication of a vector by a scalar. So, as we have discussed in the previous lecture, that vector basically, vector is a quantity which is having magnitude as well as direction. So what is vector? A quantity that has magnitude as well as direction. So if we consider a point A and a body, it is displaced from A to B. So this 3 meter basically is its displacement which is a vector quantity. So this displacement from A to B, a body is moving which has traveled 3 meter distance, and it has traveled this 20 degrees north of east. So displacement is a vector quantity which is represented by an arrowhead. As we know that vector is represented by arrow which is pointing in a particular direction from A to B. A is tail of the vector and B is head of the vector. Vector AB is represented by an arrowhead. It could be written as AB vector or simply A. Length of the arrow is telling us about its magnitude. Magnitude of AB, we have already discussed that it is represented by brackets, and arrowhead is telling us about its direction. So this vector AB, or simply a vector A, it is having magnitude as well as direction. Let's consider different types of vectors. Okay, so all these vectors, they are different types of vectors which are having some are having common points. Okay, so first let's discuss such type of vectors which are having a common starting points. Okay, so all these vectors, they are very easy to compare. Okay, how we are going to compare these vectors? Check this out, that if we are having different vectors which are having common starting point, okay, such type of vectors are known as co-initial vectors. What are they? They are co-initial vectors, 2 or more vectors having the same initial point. So all 3 vectors are co-initial vectors. Okay, so if we are going to consider these vectors which are parallel to each other, okay, their direction might not be same, but they are parallel to each other or parallel to line L. So irrespective of their magnitude and direction, so these type of vectors are known as collinear vectors which are parallel to each other. These are collinear vectors. Okay, and if we are having these 2 vectors which are equal in magnitude and their direction is same, such type of vectors are known as equal vectors. Okay, same magnitude and same directions, these are called equal vectors. Okay, and their position, their starting position is not important. It doesn't matter that what is their initial point. Okay, so irrespective of their initial point, we say that these 2 vectors are important. Okay, their initial point is different, A and C, but still these are equal vectors. It is very important point. Parallel displacement of a vector doesn't change its magnitude and direction. So we can just move a vector from one place to another place. Okay, we can move a vector from one place to another, that will remain the same, its effect will remain the same. These type of vectors are known as free vectors. Okay, so we can take a vector from one place to another place. It does not change its magnitude or direction or its effect. Okay, so these 2 vectors are still equal vectors. Okay, so we can compare 2 vectors. That is very easy for us now to compare 2 vectors. Let's say we are having different vectors AB, OV, let's say we are taking all these vectors to a common point, and now it becomes very easy for us to compare that what is their magnitude, what is their angle. So comparison of a vector is very easy because we can move these vectors, it is not changing its effect. Okay, so this displacement has become easy for us to compare all these vectors. Okay, we have already discussed that what is negative of a vector. Negative of a vector is basically if we are having same magnitude, vector having same magnitude but opposite direction, that will be negative of a vector. Means if we are having vector CD, okay, and we are taking the vectors, another vector CD which is having same direction but same magnitude but opposite direction, that will give us negative of a vector. So DC is the negative of the vector CD. Okay, so these two are negative of each other. So DC is equal to minus CD, another vector EF, that is also negative of CD. So we can say that if two vectors are having same magnitude and opposite direction, these are called negative of the vector. Okay, and if we are having two vectors which are having same magnitude and same direction, then these two will be known as equal vectors. Okay, same magnitude, opposite direction, negative of a vector, same magnitude, same direction, equal vector. So now let's check out that if we are having two vectors, can we add these two vectors? Is it possible for us to add the vectors? We will check this out in this lecture, that whether it is possible for us to add two vectors or not. As we have already discussed this thing, that addition of vectors is not possible by ordinary algebra. We cannot use simple rules for the addition of vectors. So we have to follow some specific rules for the addition of vectors, which we will discuss in this lecture. Okay, so we are having one method, graphical or geometrical method of addition of vectors. Okay, what does this method states? That vector may be added geometrically by head to tail rule. That is a rule to add vectors, very simple rule. We will discuss that in detail. Sum of the vectors is represented by a single vector called resultant vector. Okay, we are adding all these vectors and that will give us just a single vector which is known as resultant vector. Just like we are having a lot of distance, but displacement is just from starting to initial point, shortest distance from starting to final point. Same is the case over here. Resultant vector is from starting to ending point. It is a simple vector from starting point to the ending point. We will discuss that in detail. So aligning vector head to tail and then drawing the resultant from the tail of the first vector to the head of the last. Okay, so we are having different vectors. These vectors are aligned such that the tail of first is aligned with the head of last. Okay, so what is the resultant vector? Tail of first to the head of last, that is giving us the resultant. Okay, let's check it out in detail. What is head to tail rule? We have to follow some steps. First step, draw a starting point such as origin. Let's take a starting point of your figure where you are going to draw the vectors. Second step, decide a suitable scale. This decision for a suitable scale, that is important. Like if we are having vector which is force, okay, let's say we are having 100 Newton force, we cannot draw that 100 Newton force on paper. So first we will select a suitable scale. Let's say we say that 20 Newton is equal to 1 centimeter. So 100 Newton will be equal to 5 centimeter. So instead of drawing 100 Newtons, we can draw a 5 centimeter line. So decision of a suitable scale, that is important. Step 3, draw vector A to scale. We will draw first vector. Okay. Step 4, vector B's tail begin at vector A's head. Draw vector B to scale. What we will do, we will draw second vector whose initial point will be at the ending point of first vector, because we have explained this thing that if we are moving one vector from one place to another, it does not change its effect. Okay, so we can move vector B anywhere. So we are putting tail of vector B to the head of vector A. Step 5, draw a line connecting the initial start point to the head of B. This is the resultant. Okay, we have to connect initial point, starting point to the head of the last vector. This will give us the resultant. And last step, measure the resultant's length and convert this using your scale into the correct units. Like we have converted newtons into centimeter, and in the end we will again convert centimeters into newtons. Okay, so what we have to do in head to tail rule, first what we will do, we will take a starting point, and this starting point, let's say over here it is the origin. We are drawing vector A to the scale. We will select a suitable scale and we will draw first vector. Okay, then we will draw second vector, which is starting at the head of first vector. Tail of the second vector is starting at the head of first vector. We will draw this scale without changing its magnitude and direction. We have to draw it over here. Okay, and to find out the resultant of these two vectors, what we will do, we will draw another vector whose tail will coincide with the tail of first vector and whose head will coincide with the head of last vector. So this vector is giving us the resultant of vector A and vector B. Okay, so this resultant is having same effect as that of vector A and vector B. So this resultant is giving us same effect as that of vector A and vector B. So we can replace these vectors by this resultant vector. Okay, so this was head to tail rule. Okay, so again same thing, if we are having two vectors, okay, let's say this is vector A, we are moving 1 kilometer in this direction, vector A, and then we are moving 2 kilometers in this direction. We are reaching this destination and we are again starting from our initial point and we are reaching the ending point directly. We are drawing this vector, which is basically the resultant displacement, so which is giving us the same effect as that of these two vectors. Okay, we are connecting these two vectors by head to tail rule, and we are drawing the resultant by joining the tail of first vector to the head of last vector. So it is having the same effect, means if we are traveling this much distance, that would be same as that of this much distance in effect. Okay, we will reach the same destination. So if we are going to add vectors, we will consider an example. What is the resultant of 7 Newton horizontal force to the right and a 12 Newton force vertically down? Let's consider an example. We are provided with two forces. One is 7 Newton horizontal force to the right and 12 Newton force vertically down, and we have to find out the resultant. So first we will select the suitable scale. Let's say we are having scale 1 centimeter is equal to 1 Newton. So that will give us 7 Newton is equal to 7 centimeters and 12 Newton is equal to 12 centimeters. Okay, so first we will draw a vector of 7 centimeters, which is giving us 7 Newton force, and it is given that it is horizontal force to the right. Okay, so horizontal force to the right, we have drawn this 7 centimeter vector. Okay, then we will draw 12 centimeter vertically down. You can see 12 Newton force vertically downward. That's why we are drawing this vector 12 centimeter vertically downward. Now we will find out the resultant force, resultant of these two forces. That is, we will coincide the tail of first vector to the head of last vector, tail of first to the head of last vector. That will give us the resultant vector. If we are going to measure this length with scale, that was 13.9 centimeter, which is equal to 13.9 Newton. Okay, and if we are going to measure this angle with protractor, that will give us 60 degrees. So we can say that we are having 13.9 Newton force at 60 degrees below horizontal line. In this way we can find out the resultant force, which is having the same effect as that of individual forces. Let's consider another example of perpendicular forces. A man travels 120 kilometers east, then 160 kilometers north. Calculate his resultant displacement. So you can see here, a man is traveling 120 kilometers east. We have drawn it. First you have to select a suitable scale and then you have to draw it. it's up to you that what scale you are selecting. It's up to your convenience. Then it is traveling 160 kilometers north. This is the starting point of the resultant, and this will be the ending point, tail of first to the head of last vector. So we will draw the resultant from tail of first to the head of last vector. This was the horizontal component and this was the vertical component. Okay, so this hypotenuse is right now, it is known as resultant, okay, for perpendicular forces. Another example, if we are having two forces in the same direction, then what we have to do, we have to simply add them. For example, a man walks 46.5 meters east, then another 20 meters east, same direction, okay. Calculate his displacement relative to where he started. So he traveled 20 meters east, 46.5 meters east, and then he traveled another 20 meters east, okay. So he is traveling along the same direction. So its resultant will be simply by adding these two vectors. So we will get this resultant, which is 66.5 meters east. This is the resultant vector, okay. So magnitude relates to the size of the arrow and direction relates to the way the arrow is drawn. So arrow is telling us about the direction and its size is telling us about the magnitude of the given physical quantity, whether it is distance, force, displacement, whatever is there, okay. Not the distance, distance is scalar quantity, displacement. Another example, a boat moves with a velocity of 15 meters per second north in a river which flows with a velocity of 8 meters per second west. Calculate the boat's resultant velocity with respect to due north. Okay, so what over here, what is the given? A boat is traveling 15 meters per second north, okay. So boat is traveling 15 meters per second north, then it is traveling 8 meters per second west. We have to find out the velocity of the boat. So again we will use head to tail rule and we will find out its resultant velocity from head of tail of first vector to the head of last vector, okay. So that will give us resultant velocity. So if we are going to measure this angle with protractor and this resultant with scale, that gives us 17 meters per second at 28.1 degrees west of north, okay. So another example, a storm system moves 5,000 kilometers due east, then shifts course at 40 degrees north of east for 1500 kilometers. Calculate the storm's resultant displacement. Okay, let's say we are having a storm which is moving 5,000 kilometers east. So first you will select your scale. It is up to you what scale you are selecting. I am just writing it as it is. So we are having 5,000 kilometers east, okay. Then it is shifting its course to 40 degrees north of east. If you remember the directions which we have already discussed, in directions we were having these directions, that north, south, east, west. This was north of east, east of north, south of west, west of south, north of west, west of north, south of east and east of south, okay. So these directions were given. So we can use the direction over here is north of east. So we will use this direction. In the given example, we are having north of east. So we will use this direction, north of east, okay. 1500 kilometers, 40 degrees north of east for 1500 kilometers, okay. So over here we have to draw the resultant. Again, it will start from the tail of first vector to the head of last vector. If you're just provided with a figure and you have to identify the resultant in that figure, you can simply check this out, that which one is resultant. If this figure is given and we have to check out the resultant, you can see that this line is having two tails coinciding and two heads coinciding, okay. We are having two tails and two heads coinciding. Two tails are coinciding over here and two heads are coinciding over here. So we can say that this line is representing the resultant. No other line is having two tails and two heads coinciding at both ends. So this one is the resultant. Okay, so we can say that this resultant is making an angle theta, and if we are going to find out with the help of scale, after conversion we will get 624.2 kilometers. Okay, we are just discussing graphical method right now. We can calculate it using trigonometry, which we will discuss later. So right now we are just checking out that what is head to tail rule and how we are going to add the vectors using head to tail rule, which is graphical or geometrical method of addition. So we can say that 6224.2 kilometers at 8.92 degrees north of east. This is basically the resultant. Okay, right now you have to calculate the length of resultant with scale, and you have to measure the angle with protractor. Because we are using geometric method, we are using graphical method. Over here we are not doing any other calculations. So again, if we are talking about, we have done about the directions, okay, north of east, east of north, and all these things. So you have to remember these directions. These directions are important because these are provided, they are just providing this direction in the numerical, and you have to plot the direction yourself. So keep these directions in mind. Okay, addition of vector. There is another way of adding the vectors, which is known as law of parallelogram. It will give us the same resultant as that of head to tail rule. It's up to you that which method you are using. That head to tail rule is the simple one. Law of parallelogram, let's discuss that. You should know about this thing. Okay, but it's up to you that which method you people are using. So let's say we are having a vector P. Okay, don't forget to put this arrowhead on the vector symbol, otherwise it will represent a scalar. And we are having another vector Q. Okay, and we have to add these two vectors. Right now you can see that they are having common point. They are not representing head to tail rule, because if it was head to tail rule, then vector Q would be drawn like this, okay, with P. But over here we are having P and Q vectors which are having which common starting point. So we are having this P and we are having this Q. If we are using law of parallelogram, then we will draw a vector parallel to Q and we will draw a vector parallel to P. So we are drawing vector parallel to Q over here, and we will draw another vector parallel to P over here. Okay, so you can see we are having a parallelogram. So we will draw a resultant vector. We will start from the point where two tails are coinciding, and we will end where two heads are coinciding. So this will give us the resultant. Okay, we will start from the point where two tails are coinciding, and we will end at the point where two heads are coinciding. So this will be our resultant vector. Okay, so whether we are using the law of parallelogram or we are using law of you can say head to tail rule, the resultant will remain same. Okay, so that is our resultant. So if we are having more than two vectors, then what we have to do, we will place the tail of the second at the head of the first, and we will keep on doing this. Tail of the third with the head of second, tail of the fourth with the head of third, and up to so on. Okay, the resultant points from the tail of the first to the head of the last vector. Okay, so if we are having more than two vectors, then what we will do, we will simply, you can see that we are having this vector A, we are placing tail of second vector with the head of first. Okay, and then we are placing tail of third vector with the head of second, and this is our ending point, this is our starting point. We will draw the resultant from the tail of first vector to the head of last vector. So this resultant D is right now equal to A plus B plus C. Okay, so this resultant is equal to A plus B plus C. So we can add any number of vectors by using head to tail rule, simply by plotting tail of the next vector with the head of previous one. Okay, so this is simply the head to tail rule of vector addition. So again, another example, if we are having more than two vectors, let's say we are having this vector A, we will place the tail of second vector with the head of this first vector, you can see, then tail of third vector with the head of second vector. So these three vectors are added and their resultant will be starting from tail of the first to the head of the last. So this will be the resultant of these vectors. Directions will be given in the question. You have to draw the vectors according to those directions. Then according to head to tail rule, you have to place those vectors and then you can draw the resultants. That's a simple thing. For example, if one vector P is provided in this direction, Q in this direction, R in this S in this direction, we are not using R because R is representing resultant over here, that's why we are skipping R and using S. T in this direction and U in this direction. Okay, so what we will do, we will start drawing from vector P. We will take this vector P and we will move this vector, tail of this vector to the head of this vector. Okay, we will move tail of this vector to the head of this vector and we will just take this vector and move it over here. This will not change its effect if we are not changing its magnitude and direction. Okay, so we can take this vector anywhere. So how we will get the figure like this. Okay, how we have drawn vector P, then we have drawn vector Q, tail of Q with head of P, then tail of S with head of Q, then tail of T with head of S, then tail of U with head of T. Okay, so in this way we have drawn this polygon. So resultant will be from tail of first to the head of last. So if we are having any number of vectors, we can add them by using head to tail rule. Okay, simply by placing the tail of next vector with the head of last, and if all the vectors are finished, then we can draw the resultant by connecting tail of first to the head of last vector. Let's consider an example. A bear searching for food wanders 35 meters east. Okay, over here 35 meters east, then 20 meters north. Frustrated, he wanders another 12 meters west, then 6 meters south. Calculate the bear's displacement. Okay, now we are having two methods to solve this. First, we can simply, it's up to you what you are going to do, simply join the tail of first to the head of last, or you can subtract these two parallel vectors and then you can draw the displacement. It's up to you. Okay, if you are going to subtract the vectors, then how you are going to do that? You can see that these two vectors are parallel to each other, and after subtracting we will get 23 meters east. Okay, so we have subtracted this vector and this vector and we are getting this resultant. After that we will subtract these two vectors, which will give us 14 meters. Okay, so this and this vector, we have subtracted it to get 14 meters north, and now we can simply add these two resultants. Okay, we can simply add these two resultants and we can get this resultant. So you can see, if we are doing it directly, then again same resultant is obtained. So you can follow whatever steps you want. You can do it directly or you can follow these steps. It's up to you. Resultant will be same with some angle. So here we are having 26.93 meters, 31.3 degrees north of east. Okay, so this is the resultant. So what we have done, addition, when two vectors point in the same direction, simply add them together. When vectors are added together, they should be drawn head to tail to determine the resultant or sum vector, and the resultant goes from tail of first to the head of last vector. Okay, this was for vector addition. Okay, so we can add two vectors either by law of parallelogram or by head to tail rule. Okay, you can see either we can add AB by head to tail rule. You can see here a plus b, which is giving us c is equal to a plus b, or we can add b plus a, that will again give us c, okay, or we can use law of parallelogram, again same resultant, all are giving same resultant, and if vectors are pointing in the same direction, then what we will do, we will simply add these two vectors and we will get this resultant, and if vectors are pointing in the opposite direction, then we will simply subtract these two and we will get a resultant which is having less magnitude than these two vectors, okay, sum of these two vectors. So c is equal to a plus b. We can add vectors in all these ways. So what about scalar multiplication? If we are going to multiply a vector with a scalar, okay, multiplication of a vector by a scalar will result in a vector b. We will be having another vector whose direction will be same if we are having positive scalar, and its direction will be changed if we are having negative scalar, okay. So magnitude is changed but not the direction. What does it mean? It means that if we are having, let's say we are having a vector of length 2 centimeters and we are multiplying it with a scalar 3, then this vector will now have magnitude 3 multiplied by 2, which is 6 centimeters. Its magnitude will increase, its length will increase, okay. If we are having a positive scalar, its length will be increased, and if we are having a negative scalar, then its direction will be changed, okay. So if alpha is equal to 0, then what will happen? New resultant vector is equal to alpha a, which is a null vector or 0 vector, and if alpha is negative vector, it changes magnitude as well as direction. Right now I am not using arrowheads on these vector symbols. Why? Because I am using bold symbols, I am using bold letters, while in your notebooks, in your registers, you have to use arrowhead. That is must, otherwise it will represent a scalar, okay. So what does this mean, multiplication of a scalar? You can see if we are having c as a scalar, then product CA will be having magnitude like this. You can see if we are having a vector A which is having this magnitude, okay, and we are multiplying it with a scalar which is 2. We are multiplying this vector with a scalar which is 2. It will double its magnitude. Its magnitude is increased, but its direction will remain as it is because we are multiplying it with a positive scalar 2. So it will just double its magnitude. Multiplying a vector with a scalar, positive scalar, will simply increase its magnitude, nothing else, okay. But if we are multiplying a vector with a negative scalar, we are multiplying this vector A with -3, okay, so it will increase its magnitude 3 times and it will also reverse its direction because a negative sign is there, and you know that negative of a vector is having reverse direction, okay. So we can say that if we are going to multiply this vector with a negative scalar, that will give us a vector which is having increased magnitude and opposite direction. Is it clear? So if we are going to multiply a vector with a scalar, it will definitely change its magnitude. If it is positive scalar, direction will remain as it is, and if it is negative scalar, then it is changing its direction as well, okay. So if we are going to discuss about rules of vector addition, we are having some rules of vector addition, that vector addition is commutative, okay, means it doesn't matter that whether we are adding a plus b or we are doing b plus a, okay. It does not matter that what is the order of addition, result will remain same. For example, you can see over here that we are having vector a and vector b. First we are placing vector a, and then at the head of vector a we are placing vector b. So our resultant will be this a plus b, okay. And over here what we are doing, first we are drawing vector b and then we are drawing vector a, and again the resultant is same, a plus b. So it doesn't matter that what is the order of addition, you can place any vector first and any vector at the second place, it doesn't matter, it will give you same result. So vector addition is commutative. Okay, it is having commutative property. Okay, so it doesn't matter that whether what is the order of addition, whether you are using q plus p, this will be the resultant, or you are using p plus q, again the resultant will remain same. So order is not important, so p plus q is equal to q plus p. So commutative law holds in vector addition. Okay, so vector addition is commutative. So whatever the path you are following, resultant displacement will remain same. It is irrespective of the path followed, net displacement, resultant displacement will remain same. Okay, so we can say that vector addition is commutative. And you can see over here, if we are having three vectors a, b and c, so we are adding these vectors in different orders, we are getting same resultant. Okay, we are getting same resultant all the times. So you can just take any random vectors on your registers and you can practice this thing. You can change the order of those vectors, you will get same resultant all the time. Okay, so we can say that vector addition is commutative. So associative law, if we are having three vectors and we are adding two vectors first and then we are adding third vector with their resultant, we will get same result if we are changing the order. We are adding other two vectors first and we are adding third vector with the resultant of these two vectors. Okay, so order again is not important, so vector addition is also associative. Let's check this out, that if we are having three vectors a, b and c, you can see over here vector a and vector b, we are first solving these parentheses, we are first adding vectors a and b. Okay, we are adding vector a and vector b, we will get the resultant a plus b. Then in this resultant a plus b, we will add c. Okay, in this resultant a plus b, we have to add c. So in this a plus b, we are adding vector c. Okay, we are adding vector c over here and we will get the resultant a plus b plus c. This is our final resultant. Okay, now let's change the order. We are solving right hand side over here. First we will solve the parentheses, we will add b and c. Okay, we are having this vector b and we are having this vector c. We are adding these two vectors, we will get the resultant b plus c. So you can see over here, now in b plus c we have to add a. Okay, so we have to add a in b plus c. You can see b plus c plus a. We are adding a with b plus c. So what is our resultant? A plus b plus c. You can see same resultant over here. So it doesn't matter that what is the order, associative property also holds in vector addition. Distributive law, distributive property again holds in vector addition. If we are having any scalar m and we are multiplying it with resultant a plus b, then this sum is equal to ma plus mb. Okay, so if we are adding a plus b and we are multiplying the resultant with m, that will give us ma plus mb. So you can see over here a b, resultant is a plus b, and ma and mb, that will give us ma plus b. Okay, so distributive law also holds. Is that clear? That if you are having a, b and a plus b and we are multiplying both sides with m, that will give us the same result. So distributive property also holds in vector addition. If we are multiplying all the vectors with same number, then it will not change the effect. Okay, just it will be enlarged, it will be multiplied with the scalar with which we are multiplying. Let's say if this m is 2, then all the vectors, they will be doubled, and if this scalar is 3, all the vectors, they will become 3 times. But distributive law holds for vector addition. What about subtraction of vectors. How we are going to subtract? We are not having any direct method for subtraction of vectors, so it is again similar to the addition of vectors. What we do, equivalent to adding the negative vector. It is just equivalent to adding the negative vector. For example, if we are finding vector c, we have to find out c, which is equal to a minus b. Then what we will do, we are having vector a, we are having vector b. We will simply reverse the direction of b. We will write it as minus b and we will add it in a. That will give us a minus b. We will simply, first step, just one step is added. In addition, just one step is added. First we have to reverse the direction of the second vector and then we will add these vectors, nothing else. That is equivalent to the adding the negative vector. Okay, for example, you can see over here that if we are having vector a and we are having vector b, we have to subtract these two vectors. Then first we will find out negative of this vector. We will just reverse the direction of this vector. Okay, we have drawn minus b over here and then we are adding these two vectors by head to tail rule. So this will give us a minus b. So subtraction is simply adding negative of the vector. So we will first find the negative of the vector and then we will add these two vectors. Okay, so again same thing, if you are having this vector a and we have to subtract b from this, then first we will find out minus b. We will reverse the direction of b over here. You can see minus b is here, a plus minus b, and then by head to tail rule we will add these two vectors. Okay, we are putting the tail of this b with the head of a. We are putting tail of minus b with head of a. So these two vectors we will be having this resultant. Okay, so over here a plus minus b is equal to a minus b, which is the resultant. Okay, so we simply have to add these two vectors to get the final result. So subtraction, when two vectors point in the opposite direction, simply subtract them. Okay, just we have already done this thing, that if we are checking out the example, a man walks 46.5 meters east, then another 20 meters west. Okay, 20 meters west. Calculate his displacement relative to where he started. So we will simply subtract these two vectors and we will get the answer, which is equal to 26.5 meters east. Okay, because these two vectors up to this point, they will cancel the effect of each other and just left will be this portion. So this direction is along east. Okay, so we will get this resultant. So negative of a vector is the vector of same magnitude pointing in the opposite direction. You know this thing. So if we have to find out a minus b, a is this vector, b is this vector, we will first find negative of this vector minus b, same magnitude but opposite direction. Then we will place tail of minus b with head of a, and in the end we will find out the resultant. So d is equal to a minus b. This will give us the resultant. So it is simply adding negative of a vector, nothing else. From book, check out example 2.1, page number 43. Statement is a ship leaves port and travels 200 kilometers at 30 degrees north of east. So this is our given data. Ship is traveling 200 kilometers at 30 degrees north of east. Then it changes its direction and travels 350 kilometers in a direction 140 degrees north of east. Again same direction but angle is changed. Okay, initially it was 30 degrees and now it is 140 degrees. Distance is again changed, 200 kilometers and 350 kilometers to reach the destination. Calculate straight line distance covered by ship, means you have to find out the resultant. So you have to follow the same format. You will first write down the given data, then required, and then you have to solve it. Okay, so for given data, first procedure, select the scale. Let 50 kilometers is 1 centimeter. So 200 kilometers, which was in the given data, that is equal to 4 centimeter, and angle was given, which is 30 degrees north of east. 350 kilometers, which is 7 centimeters, and theta is 140 degrees north of east. So we have taken 50 kilometers is equal to 1 centimeter. That's why 200 kilometer is equal to 4 centimeter and 350 kilometer is equal to 7 centimeter. We have selected the suitable scale, and after that we have to write down the required data. Resultant is required, and solution, finding the resultant. What we will do, using head to tail rule to find the resultant r, we measure the length of resultant r with scale. Okay, we are not using any trigonometric ratios over here. We will use scale and protractor to solve this. Okay, so let's check it out. What we have to do, first we have selected the suitable scale, 50 centimeter, 50 over here, 50 kilometers should be there. 50 kilometers is equal to 1 centimeter. So we will select a starting point, and first we know that it travels 200 kilometers at 30 degrees north of east. So check out the directions, north of east. This is north of east, so it is traveling 200 kilometers. So this will be 200 kilometers, which is 4 centimeter, 30 degrees. Okay, so we are drawing the figure according to the given data. 30 degrees, direction is north of east, and its magnitude is 200 kilometers, which is 4 centimeter. Then secondly, it is changing its direction and it travels 350 kilometers in angle 140 degrees. Now we will draw angle of 140 degrees. Okay, and its magnitude is 350 kilometers, which is equal to 7 centimeter. You can name these points as A, B and C. Okay, so over here you can see we have drawn all the given vectors, all the given displacements. Okay, now we have to find out the resultant displacement or straight line distance, starting from the tail of first vector to the head of last vector. We will draw the resultant. So you can see over here, this is our resultant, which is making an angle 106 degrees. We have calculated this angle with protractor. Okay, so 106 degrees, its magnitude AC is equal to R. So resultant is 6.8 centimeters. We have to multiply this 6.8 with 50. We will get 340 kilometers, 106 degrees with east. Okay, so don't forget to use arrowheads. I am using bold letters, that's why we are not using arrowheads, but in your notebooks you have to use arrowheads. That is very important. Okay, so we are having resultant 6.8 kilometers centimeters, which is equal to 340 kilometers, and angle is 106 degrees with east. Okay, this 6.8 centimeter is measured with scale. So what you have to do, you have to measure the length of this resultant with scale, and you have to calculate this angle which it is making with positive x-axis with protractor, and you will get the resultants. That's very simple. Okay, so our result, length of vector is 6.8 centimeter, which we have to multiply with 50 kilometers, and we will get the result 340 kilometers, and angle calculated is 106 degrees with east. Okay, so this is our result, 340 kilometers, 106 degrees with east. This is the straight line distance which is covered by the ship. Okay, so which it has traveled 200 kilometers and then 350 kilometers. Okay, so straight line distance is less as compared to those changing distances. Assignment 2.1, which you have to do it yourself. Again, exactly the same things, you just have to draw the vectors and you have to find out the resultant. An airplane is moving at 120 meters per second at an angle of 10 degrees with x-axis. First select a suitable scale and then draw these vectors. Through a 30 meter per second crosswind blowing at an angle of 260 degrees with x-axis, draw these two vectors. Using head to tail rule, find out the resultant velocity. Okay, you can do it. Okay girls, I would like to end my lecture with this quote, that one of the basic rules of the universe is that nothing is perfect. Perfection simply doesn't exist. Without imperfection, neither you nor I would exist. Stephen Hawking. Okay, so there is no perfection. Okay, imperfection is always there. Just try to do your best. Just try your level best. Okay, and don't stop. Don't you can say don't leave your goal, and you will achieve whatever you want one day, inshallah, with the help of Allah Almighty. Thank you so much. That was all for today's lecture.